Okay, let's do the 13B lectures. 13B. Alright. So we're going to talk about the renewables or non-depletables, or relatively non-depletable. We're going to look at the different forms of solar, passive and active here. We're going to talk about how to harness it by different types of peoples, whether they're in countries that are similar to ours or countries that are considerably less industrialized. We're going to look at how different people are able to harness things like wind and solar and geothermal. And then we're going to look at the advantages and disadvantages of hydrogen fuel cells. And the energy of the sun can be captured directly, and there's more ways to do that than just solar panels. But real quick, I want you to kind of look at this graph, because if you remember from our midterm, there were a lot of questions in there that kind of ask you to look at information in graphs rather than just ask you straight up facts. So it helps if you do know the facts, but it's a lot better if you can read information. So what do these units mean right here? Kilowatt hours, right? That's a unit of that's how our energy is measured usually. Kilowatt hours per meter square. We know meter square is how you measure area, and then per day, right? So this is the kilowatt hours per area per day. And so we look at this chart kind of moving upward. You notice that the numbers are getting much greater, higher kilowatt hours per unit of area per day. So if you had to guess based on where the really high numbers are at, even without looking at the little title at the bottom, you probably have to figure it has to do with something that has to do with solar power, right? Because think about where we're at, right? It's really hot right here, and energy produced there is really high in these regions where it's really hot. You probably figure that it's going to be something that has to do with solar power. So these are ways that you kind of want to think about this. And I had a discussion with one of your classmates today about kind of how to better read questions and strategize and think in terms of application of data. All right. So what is this about? Yeah, solar energy. Right. So how about that? All right, so active solar is what we typically think about, right? Of course, we were doing a lab that used passive solar, but active solar is capturing sunlight with advanced technologies, right? It's things that you think about, things that you normally think about when you think of solar power, right? And that's going to be photovoltaic systems, solar water heating systems, right? And then it's important that you know that a photovoltaic cell can be simply called PV cells, right? All right. Capturing energy from sunlight, converting it directly to electricity, and this is usually using some semiconductor like silicon, right? So the benefits and drawbacks to this is active solar doesn't generate CO2 to produce the energy at the point of where it's installed, and it's usually very, very good at producing energy when you would need it, right, to keep your house cool. And when's that going to be? When the sun's out. It's less expensive than running electrical transmission lines to some homes, but if you're considerably, especially if you're considerably far away from a grid or a city, right? So if, like, this is your house right here, so this is where you live, and you are, miles and miles and miles and miles and miles away from, all the cities and everything over here, right? Here's a little tower, right? So if you're considerably far away, running a power line over there might be very, very, very expensive, right? But if you were to cut this guy out and just use a solar panel on site, you might be able to save a lot of money in terms of producing energy there. But let's talk about some of the downsides. Photovoltaic panels are expensive to manufacture and install, and a lot of the times they use toxic metals, heavy metals, and industrial chemicals, right? So if you are in an area that has a lot of sunlight and you're in an area that subsidizes solar panel production, solar panel installation, you make your money back pretty quickly. But a lot of the times this isn't the case, right? Especially if you live in a third world country, or you live in a first level industrialized country, you might never make your money back. You might never have the money to even invest in solar panels in the first place. Right, so that's something to consider. Of course, our technologies are getting better, and other countries like China that are researching them and developing solar panels at a really, really accelerated rate are going to definitely contribute to the global furthering of solar panel technology. All right, and also what's really important to note is that you can't produce solar power at night, right? So what do you do with all that excess energy you get during the day? It's not. Sometimes peak energy production does not meet energy demand. So you basically have energy that you're not able to use. And so what do you do with that? Ideally, you want to store it in a battery. And of course, all these batteries, lithium, cadmium, hafnium, all that stuff is going to have its own effects on the environment. So this is one of the things we're going to talk about later when we get to hydrogen fuel cells. But this is a big issue. It's not just how efficient we can make solar panels and how much we can invest in them, but it's the very fact that solar panels, and you need to know this term, are not energy carriers. Yeah, they're not energy carriers, right? What that means is they can directly harness energy from the sun, but they can't store it on their own for later usage, right? You have to use batteries and things like that. All right, wind energy. You need to know this because they keep mentioning this, and I definitely want you to know this. Like water, like dams, like hydroelectric dams, it's using kinetic energy. Kinetic just means motion, okay? So moving air, moving energy. Moving air, moving energy. Just like water, hydroelectric dam uses the kinetic energy of falling water. Okay, wind energy is the fastest growing major resource of electricity in the world. Yeah, let's look at this graph because you want to know which countries are using wind energy. Now this is really interesting to look at here, that the greatest producer of wind energy in the world is China. We're followed by the United States. You wouldn't think the United States uses a whole lot of it, but I want you to look down at this graph. Percentage of total energy used by the wind, right? Percentage of total energy generated by wind. Even though China has the most, look, China is way down here at the bottom, right? Percentage is around 1 to 2%. So what does that mean, right? How do you read that graph? You were being asked a multiple choice question. How would you reconcile the disconnect between these two data points, right? China has the most, yet it's only 2%. That means that it's getting a lot more of its energy from other things, right? And we know from the documentaries, if you watch your documentaries on my playlist, you know that a lot of their stuff is coming from coal, right? All that coal. You can spell it correctly. Right? You're getting a lot of their stuff from coal. Right? A really high percentage of solar panels, of course, but the majority is still coal. If you look at their big cities, sometimes it's so hazy you can't see through it, right? So let's look at some of the other countries on here. So United States, second place. So we're around 60 gigawatts per year. It's just quite a bit of energy, right? But where are we at? We're somewhere in the middle, a little over 5%, right? I think we can definitely do better, but let's talk a little bit about the reasons why maybe it's not such a good idea all the time. Okay, so Denmark has the highest percentage generated by wind, and they're over 25%. That's pretty cool. All right, so how does it actually work? Most of these things involve turning some sort of turbine. Gets the kinetic energy from the wind, spins a turbine, which rotates some sort of magnet with a coil wrapped around it, a generator or something like that, and it stores energy that way. All right, and there's little short videos on my playlist that you should be watching to kind of look at the way it works. And it's really interesting that all of the different types of electrical generators or electrical plants all use some sort of turbine mechanisms. It's all really the same when you get down to it. It's really just the source that's different. Wind turbines are usually installed away in rural locations, away from buildings and population centers, and there are reasons for that. One is access to just clear plains and things like that where the wind is unimpeded, and two, they're aesthetically not very pleasing to a lot of people. They sometimes make noise, so that's one of the it's a goofy reason, but it's one that is a legitimate answer in an FRQ. So aesthetics, which is just pretty, pretty or not. And then you also have what was the second one I said? Noisy. And then also bats and birds. Kills bats and birds. Some people say up to 40,000 birds per year. Interesting, right? So these are really the reasons that we usually like to keep these things away from cities. Not necessarily the bats and birds, but that they're noisy, and some people think they're... Okay, so let's take a look at this guy, look under the hood. blade turned by the wind. And obviously, the longer the blade, the more efficient it's going to be. It has to do with rotational velocity. I'm going to use like the really, really simple 2 pi r over the period it takes for the blade to spin around. And so if you look, as the radius increases, right, as the radius of this circle thing here that I'm drawing out, right, it's a big circle, right, this little circle right here versus this middle circle right here, you notice that as my radius increases, that this value of velocity centripetal has to increase as well, right? It's a direct relationship. So you see that there? So what this basically means is if you do marching band or something like that, the guy who's standing right here doesn't have to move as fast as the guy standing here, which doesn't have to move as fast as this guy, or the tip of the blade. But since they all have to move at the same rate or period, the guy out here on the very tippity top of this blade has to be moving at the greatest tangential or velocity centripetal tangential speed, right? So this kind of has something to do with that, right? So that the longer the blade, the more efficient it gets to be. Of course, that's expensive, right? So what's it going to do? These things spin some sort of turbine here. Motorized, it spins the generator, converts the mechanical kinetic energy into electricity, and there you have it. So that's generally speaking how it works. That's some of the terminology. All right. So here's some of the advantages. It's considered a non-depletable renewable resource, free energy resource. Once you get this thing built, it basically costs nothing. You just have to go out there and do some upkeep every once in a while. If a bat splats into it, it makes a big mess out of everything. Don't shine the bat signal into the wind turbine, right? Okay. No pollution once you are actually generating it. Now, the process of actually making them, and going out there and maintaining them might cost some, but I'd say that that's a very minuscule cost once you look at the longevity of how long these wind turbines can produce electricity. Wind energy, here's some disadvantages. You got to use batteries. That's really, really the big thing. Noisy, unattractive. So here's the aesthetic thing. As many as 40,000 birds are killed by wind turbines in the U.S. every year. Bats are also thought to be killed by wind turbines. That's why they prefer to work alone, right? All right, so let's talk about the radioactive decay of the Earth, the geothermal energy. All right, so if you go down deep enough into the Earth, seafloor spreading and things like that, sometimes the liquid hot magma will creep its way up to the surface, and that thermal energy can boil off steam. And you know what happens when you boil off steam? You can do pretty much all the different types of power plant operations, right? Because most of the time it involves some sort of energy source heating up water and then using that heated water in the form of vaporized steam to turn some sort of turbine. And so you can just use the geothermal energy. You can use the magma to do that, right? You can use the magma to do that. So you can imagine a situation where there's like the seafloor here, and it's close enough down to the magma layer coming up. And if it's close enough to the surface, you can build some sort of factory here with some water. And this stuff will boil. And eventually it will get up enough kinetic energy to go upward or something, and you can get that to spin into a nice little fan blade or something here. It's a really terrible fan blade. But you can get this thing to spin around in a circle, right? So that's how this geothermal energy works. Right now, the United States actually uses quite a bit of geothermal. Right? China and Iceland. Iceland now, I think, is the biggest use of geothermal energy. Right? Okay, now this one's kind of interesting. Ground source heat pump is technology that transfers heat from the ground to a building. Now, this is kind of interesting because a lot of people would say that this is not actually geothermal, but it actually is solar powered. Because unlike the liquid hot magma breaking through the crust, this is actually just the ground. It's actually just the ground right here. Let's say we have a house. Looks like some of y'all's houses that you made, right? You got your house, you have the sun here. And what's the sun do? It shines down some rays, heats up the ground a little bit. And as long as you have some sort of mechanism down here filled with water, guess what you've just done? You've heated up that water, and now that hotter water hotter water, that hot water can flow through your house, right? Do all kinds of things. And then when it's done, it can cool back down, go back into here, right? So this is actually considered more solar power than it is geothermal. It's just using the ground's really high thermal inertia. It's using the thermal inertia of the ground to kind of store and trap this heat. Okay, and this is kind of how that works. You need to know these steps, generally speaking. And this picture is a lot better than mine. So heat from the sun is down here, is able to heat some of this because when it's cold, the ground is warm, so it's able to pump this water by heating it up. And when you heat up water, it expands. Goes up this way. I'm like tracing the wrong way. Goes up this way into the house. This heat exchanger is another way of just saying like the stuff that's in here gets warmed by the hotter water, right? This is the second law of thermodynamics, entropy. And entropy basically means that the hot energy that's concentrated into small spaces, like right here, will transfer its energy out into colder areas, right? Just by mixing its kinetic energy. And when it heats out, it loses its energy, and guess what? Now it's going to go through here, the steam condenses, back into water, goes back down, restarts again. And the really cool thing about this is that it's a lot more efficient. Let's finish this up. So let's talk about hydrogen fuel cells. It's an electrochemical device that converts fuels such as hydrogen, and we're usually talking about not atomic hydrogen, but molecular hydrogen, H2. Remember, like your Brinkelhoff, right? H2, it's one of your diatomic molecules. It's a lot more stable as molecular hydrogen than it is atomic hydrogen. Electrolysis is the process of breaking water molecules with electricity usually, and splitting them into hydrogen and oxygen, usually it's H2 and O2. And that's how we get H2 gas, because it doesn't occur very naturally in nature, not very abundant, right? It's combined with methane, CH4, and water, H2O, you know that, of course, right? It's combined with these two because it's a much more stable bond. It's better, it's a more favorable bond. Okay, so this is what it looks like. Basically, you have some sort of membrane. You push the hydrogen molecules in, and the protons and electrons separate. And when you do that, you end up with this potential. You end up running basically a difference in charge on both sides, and you are able to run a current that way. You're able to run a current. So you want to know this kind of process a little bit. The really cool thing about this is that this hydrogen, when it does this, it creates a product that's just water. It's just water. So you're combining hydrogen and oxygen, and it creates water. It's pretty neat, right? So why wouldn't we just always do this? Because we're producing water, we're getting stuff out of hydrogen, the most abundant element in the universe, and one of the most abundant elements on Earth. So why wouldn't we just do this all the time? Well, we're about to talk about that. Okay, so let's talk about the later half of this chapter, last part. We can't replace our non-renewables with all these things we've talked about because our energy demands are much higher than any of the things that these non-depletables and non-renewables can do for us. Even though, it's kind of funny we say that because we say that the sun produces like a terawatt of energy like every hour or something like that. So what do we mean by these non-renewables cannot replace our why are these renewable or non-depletables can't replace our non-renewables? Like why not? Well, it has a lot to do with practicality. It has a lot to do with, well, yeah, we can use solar power all the time if we don't mind not using energy at night, right? If we don't mind not being able to store it, right? But that's just not practical for what we've become accustomed to and the needs of our population, the needs of our species, right? So we have to start thinking not just in terms of renewables, but our future sustainability plan for energy consumption has to include energy efficiency, conservation, and the development of renewable and non-renewable energy sources. So what are some ways that we do that? So thanks Obama, right, came up with this idea of supporting things like the smart grid. So using computerized, linked, almost like linking up a bunch of Wi-Fi and Bluetooth things, but we're talking about factories connecting to smart appliances in your house. So your smart appliances can link into the grid and go, all right, well, there's a surplus of energy usually at this time, so let's run the dishes at 2 in the morning. Let's run the washing machine at 5 in the morning. Let's not just use energy from Bronig Lake. Let's use energy from Ohio, right? Let's use energy from Corpus Christi, because they're not using it right now. So think about it. So if you think about peak energy demands in Texas, right? We're all going to relatively have about the same time. I know we have a few time zones here, but there are places in the world, if you think about it, that are not at peak demand at all times, right? Like they might be, it's always 2 o'clock in the morning somewhere, right? So if we hooked up enough of these grids together, we might be able to efficiently, like more efficiently, use energy, right? That's pretty interesting, right? All right, so this is what that would look like. So the internet definitely has a large role to play in there. But just remember, you can't believe everything you read on the internet. And that was said most famously by Abraham Lincoln, right? He said that. Just kidding. Okay, so smart appliances. And the last thing I really want to talk about is I want to go back to hydrogen fuel cells. Hydrogen fuel cells. So the problem with hydrogen fuel cells is that it's a gas, right? It's an actual gas. So if you're trying to put that in something like a car, you'd have to, one, have a much larger gas tank. Much larger gas tank. You'd have to pressurize that fuel. And you run the risk of, one, Hindenburg. Right, nice Zeppelin, right? Nice Zeppelin that I think was used for pyrotechnics in the early 1900s. Oh no, that's right. It exploded, right? It crashed and exploded all over the place, and it was a disaster. I don't think it should have been the nail in the coffin for Zeppelins, but it definitely didn't help, right? It scared people from the prospects of using hydrogen as a fuel source, and it's not incredibly practical, right? It's very difficult right now for us to separate water through electrolysis because it takes a lot of energy. So something that we're thinking about, right, because there are explosions, explode, and it costs a lot of money. The money is very high to separate water molecules into H2 and O2. So it's something that is a problem, right? But the nice thing about hydrogen, and the reason why we're not walking away from it, and the reason that some countries are already using public transportation, like in Iceland, in Reykjavik, they use all their public transportation uses hydrogen gas tanks. And the really good thing about hydrogen is, even though it is kind of energy intensive, it's worth looking into, because hydrogen gas, H2, is an energy carrier. Okay, this is an energy carrier, which means if you just break apart molecules in H2 and store it for later, when you combine this with oxygen later, you get energy out of it. You get energy out of it. So it effectively is a battery. It's something that can store energy. So I can see a world, perhaps, where windmills and solar power things are being used to perform electrolysis, or power things that are performing electrolysis. And if you just have enough of these things, you might be able to break apart hydrogen and store it, right? And as technology gets better, we might find ways to get around the idea, or to get around the problem of exploding cars, right, from just filling up at the pump, right? So these are things to think about. I really hope that you take these things and you use them to inform yourself a little bit more about the sort of things that you were working on with passive solar, and looking at the ways that countries moving forward in the future might be able to use these. Just keep in mind that solar energy and all these renewable energy sources and sustainability, it really changes the story when you start moving from countries that are like the United States, like Iceland, like Japan, and you go to countries that most of the time don't even have power grids everywhere, right? We're talking about, in the United States, we have these things like energy parks, right? Which is something we want to move to. Energy parks are something we want to move to, where lots of little energy plants, power plants, are replacing these gigantic ones. And the nice thing about that is that if one goes out, It's not like Christmas light. One goes out, everybody goes out. It's very easy to pick up the slack for a downed plant, right? If I have, instead of one gigantic massive plant, spider veins out lines all over the place and is the hub of electricity for the entire city of San Antonio. This thing getting removed from the equation is detrimental for everybody, right? But if I do something like an energy park that looks something like this instead, and they all have their own little networks, right? And they're all intertwined. Now, if this guy goes out, it's much easier for the surrounding guys to pick up the slack, right? So these are energy parks, and of course these can all be linked up through smart grid technology. Of course, this doesn't mean anything when you live somewhere that doesn't even have running water or electricity. That makes passive solar, the things that you're studying right now, the things that you performed in your lab, much more important, right? Because the sun can still be harvested. Windmills like William Kamkwamba at the beginning of this chapter, this unit, he showed you that you can still use renewable resources and reduce pollution, reduce indoor air pollution, like we're going to learn about in the next chapter. You can keep people safe, like in Darfur, from having to go collect biomass like wood and animal manure out in the woods when they're living in refugee camps. If you can make solar ovens, right? Solar ovens. So just harvesting the sun, harvesting the wind, renewable resources all around you that can be produced with really not much technology. It's something that begs us to really help educate people more, and to make sure that people that are developing their countries, that are developing their economies, try to integrate these things as much as possible, so that they don't have the same struggles that we do when they reach the height of their industrial production. Right?